welcome to the example video. These are additional examples that aren't in the book. They look similar to the ones in the book, but the reason I give you the additional ones is so that you can always look back in the book and get more examples. So you're actually getting more examples this way. So first off, I drew this picture. We have P up here, Q over here, R over here, S here, T here, U here, and I is the vertex, that middle point of the intersection of all the lines. And up here it says, name an angle pair that satisfies each condition. So we need an angle pair. Remember, a pair is two angles. So we need two angles that form a linear pair. Let's think about what a linear pair is. A linear pair has to form a straight line because of the two opposite rays, and they also have to be adjacent. Adjacent, remember, means that it shares a vertex, it shares a side, and there are no common interior points. So we have quite a few different options for this two angles that form a linear pair. We could do, let's do angle P, I, Q, and angle Q, I, S. So we have PIQ and QIS. So they form this straight line of PS here and share the side QI. Another option would be angle TIU and angle, so we have TIU, we have to share a side, so UI, and then we have to make this T into a straight line, which makes it go up to Q. Remember that your vertex is always in the middle. See how my I is always in the middle? I always have to go there first. Other options would be SIR. Let's do SIR, angle SIR. So we have SI and R, and then we need it to share a side, so RI, and then make a straight line. So we're sharing that side RI right here. We have to make this SI into a straight line, so we're going to go to P. P, right there. Many other examples in this. I want you guys to come up with a few more. If you have any questions, if it is an example, feel free to ask me. Also, then B, two acute vertical angles. I don't think I mentioned an example of vertical angles, but remember, vertical angles are from an intersection of two lines. Guess what? We have tons of intersection here. And they're not adjacent, so it means that they have to be opposite. So let's use these intersections I've drawn in blue. And I need two acute vertical angles. So the angle would be PIT and angle QIS. I want them non-adjacent. See how they aren't sharing a side? Another one with this blue one would be angle PIQ, which is up here, PIQ, that one up there. We want the other one that's not adjacent, so it's going to be the opposite down here. So TI and S. Angle TIS. Tons more. I could do, I'll do this one in green, if you guys can tell the color difference. So I, or UR, right there, intersects with, let's do TQ, which is right there. Okay, so we notice that this forms, when these two intersect, we get an acute angle here, which is congruent, this is congruent to this one. And we get an obtuse angle here, which is congruent to this one. Remember that vertical angles are congruent? Well, we're looking for acute, so make sure that you read the full question. We're looking for acute vertical angles. So can I use these? No, because they're obtuse. So let's do these. So we get angle U, I, and T, U, I, T, and angle Q, I, and R. Angle Q, I, and R. Are there any other ones that I could do? Not with this vertical angle because I can't do these two. Now could I flip these around and have angle TIQ and angle RIQ? Yes. These are the same thing, the same angle, just a different name. So that says the same angle, just a different name. So these two are the same, they're just named differently. Okay, if you guys have any questions over example 1, look in your book. Otherwise, feel free to ask me. Now we're going to move on to number 2. So number 2 says, find the measure of 2 supplementary angles. What do we know about supplementary angles? They equal 180 degrees, straight line. If the measure of one of the angles is 6 less than 5 times the other angle. So remember that we have the measure of angle 1 plus a measure of angle 2 equals 180. Okay, so we know that the measure of angle 1 is just going to be plain x. And then we have the other angle is 6 less than 5 times this angle, okay? So we have 5 times of one angle and 6 less. So 6 less than 5 times the other angle. And this is going to equal 180 degrees. We combine like terms, so we have x's here, so we get 6x minus 6 equals 180 degrees. I'm running out of room here, so I'm going to bump up here. So I'm going to first add 6 to both sides, add 6. So 6x equals 186. Divide by 6. And x equals, 6 goes into 18. 3 times. No leftovers. So 6 goes into 6. How many times? 1. So angle x, we have one angle. Angle x is 31 degrees. So we can say 31 degrees is one angle. Now how are we going to figure out the other angle? We need 2 angles. The other angle is going to be 180, our total angle measure, minus 31. 7, 1, 9. 7 minus 3 is 4. So we get 149 degrees. Those are our answers. There's another example like this in the book. These are some of the hardest problems. I really encourage looking these up in the book. I'm going to do 2 more examples. It's going to take me a bit to draw them, and I'm going to erase this, so if you need to pause the video, feel free to do so now. Okay, so our next example is example 3, and it says find x and y so that KO, the line KO, and HM are perpendicular. Okay, so remember, first off, we have a picture here, so I'm going to draw this picture. Give me a bit to draw this picture. It's one part about geometry. We have lots of pictures. Remember that little square means perpendicular or 90 degrees. And we have here that 3x plus 6 is this angle measure right in there. And we know that this angle measure is 9x. And then up here we get 3y plus 6 for that measure. Now we want, okay, remember, this isn't here originally, okay? We want that's an HO, we want this line, or KO, right here, this line KO, drawing it right there, and HM to be perpendicular. What does perpendicular mean? Forming right angle, right? Okay, so they form a right angle, so I'm going to draw this in. What's a right angle measure? 90 degrees. So, right over here we know that this has to equal 90 degrees. So we have 3y plus 6. We know that if that angle right there is 3y plus 6, we also know it's 90. So it equals 90 degrees. So we do the math. We add 6, we get 3y equals 96. We divide by 3, and we get y, that's a y, equals 3 goes into 9 3 times, no leftovers, 2. Okay, we get y equals 32, not 32 degrees, just 32. So we have this. Are we done? We're done with y. But guess what? We have x left. Make sure to read the question. We are not done yet. So we realize that when we have a perpendicular line, they form 4 right angles. So that's a right angle, this is a right angle, and that's a right angle. Just like in line segments, 2 smaller sections equals a full section. So this smaller section plus this smaller section equals that 90-degree section. So guess how we're going to do that? We're going to add them just like we did with line sections. So we have a 3x plus 6. That's that one section plus the other section plus 9x. And that full section is going to equal that 90 degrees. 90 degrees right there. So how are we going to solve for x? We are going to first combine like terms. We have a like term there and a like term there. So we get 12x plus 6 equals 90. We're going to subtract 6 to both sides. Subtract 6. This should have been a subtract. I messed up here. This should be subtract 6. That's how we get it to the other side. So let me correct this. Subtract 6. Subtract 6. That does not equal 96. That equals 84. 84 divided by 3 equals 28. I am sorry about that mistake. 28. So we have y equals 28, not 32. That was my bad. So then we get 12x. 12x equals 84. Then we do the handy dandy divide by 12. Divide by 12. And we get x equals, and x equals 7. Okay, so now are we done? We have x and we have y. So yes, we are done. I circle my answer so it's easy for the teacher to find, aka me. And we're going to do one more example. So I'll let you write that down. If you have any questions, feel free to ask me. And we're going to move on to number 4. Okay, 4 is our final and last example. Thank you for bearing with me during this drawing and writing process. Okay, so our next picture looks like this. line there. Straight line here. We have a T down here. T as in turtle, X as in xylophone. Y is our intersection here. That's a Y. Then we have a V over here. And we have a line coming down this way. And this is a U. And then we have a line going up this way, and we have a W. And then we have a little line coming down this way, and this is an S. This is number 4. Okay, and we want to determine whether each statement can be assured from the figure. And explain. If you don't explain, you will get half off. Big points right there. So the first one is the measure of the angle VYT equal to 90 degrees. And we do have a little square right there, okay? So it's the measure of VYT equal to 90. So we find V, we find Y, and we find T. So we found V, Y, T. Is the measure of that angle 90? The answer is yes. The reason that the answer is yes is because V and Y, so the VY, that line VY, this line here is perpendicular to this line here, TX. How can we tell that they're perpendicular? With this little square right there. And when we have a perpendicular line, guess what? We get 4 right angles, right? So yes, that one can be assured. The next one we have is the measure of angle T, Y, and W, and angle T, Y, U are supplementary. Okay, can we be assured that they are supplementary? So first off, we need to find them. We have T, Y, and W. So T, Y, and W, and T, Y, and U. So T, Y, and U. So does this essentially make a straight line? Yes. Yeah. Yes. They form a linear pair of angles. Okay. And our last one is our angle VYW and angle TYS adjacent. Are they adjacent angles? So let's find them. So we have V, Y, and W. So we have VYW, this angle right here, and TYS. So we have this angle right in here. Okay, so for them to be adjacent, remember that they have to share a vertex, shared a vertex, and they have to share a side. Whoops, they don't share a side, so this is a no. They don't have a common side. I hope this example video helps you guys. If you guys have any questions over the material that we went over in this example video or over the homework, feel free to contact me. You guys have my email. Otherwise, stop by anytime and I'll get a time set up to meet with you guys. So hopefully this helped and I look forward to seeing you in class.